separate everywhere exercise. So now let me explain you full wave rectifier. Before explaining the operation, let me give a definition of full wave rectifier first. Then I will go to the what will happen here. Listen carefully. Half a rectifier will rectify only one half of the AC side. Now when it comes to full wave rectifier converts alternating current or alternating voltage to pulsating constant DC voltage or DC current for both of the half cycles. It will convert AC voltage or AC current to pulsating DC voltage or pulsating DC current for both of the input half cycle. This is my positive half cycle, this is my negative half cycle. Both the half cycle will be converted, that AC will be converted to pulsating DC. That is nothing but full wave rectifier. When you take half wave rectifier, it will rectify only one half of the AC cycle, that is positive half cycle. But when you take full wave rectifier, it is rectifying both the half cycles. Understood with the definition? Say some. Say some. It was rectifying both the half cycle. It will convert positive half cycle and negative half cycle to pulsating DC, constant DC. Now as I said, focus here. Now let me explain you the operation of this full wave rectifier. How does it works? As I said, whenever you are answering, whenever you are writing the answer, what is my first case? For positive half cycle. Focus here. Now I am explaining about operation. For positive half cycle, keep in mind whenever you are connecting positive, a positive will come this side, negative will come this side. Say so, no? Say so. Now before telling this, here I have drawn a tap, a dot, and I have made it as grounded. I hope you know this. What do you mean by this? Ground. This is nothing but center tap transformer. This is nothing but in the middle center tap transformer. In the full wave rectifier, we have a center tap transformer. Why we need this? Because I want to convert the complete cycle AC to DC. In general, let me tell you, when you see this center tap transformer, this is one wire. What is this? This is one wire. This is second wire. This is third wire. Three wires. How many? 1, 2, 3. Now 230 volt will be stepped down to 5 volt. Here 5 volt. This is grounded, means how much? 0 volt. Grounded means 0 or negative. Listen here. Either you can use this wire and this wire plus 5 volt and grounded, or you can use this wire and this wire. This 0 is common wire. Plus 5 volt grounded, or this plus 5 volt grounded. When you see practically center tap transformer, you will have 3 wires. Plus 5 volt, 0, plus 5 volt. Clear, understandable? Say some. Say some, clear. Now I am telling that for positive half cycle. Now I will come here. For positive half cycle, this end will get positive, this end will get negative. Negative means this grounded. What will happen now? I am applying a positive here. This is anode, this is cathode, this is anode, this is cathode. Here it is getting negative, here it is getting positive. What will happen? Which diode will conduct forward bias? Upper means which one it is? D1. Focus here. I am applying a positive half cycle and a negative here. Anode of diode D1 will get positive. Anode of diode D2 will get negative. So positive to the positive, it will become forward bias. Negative to the positive, it will become reverse bias. So now I will write here first case for positive half cycle. D1 is forward bias, D2 is reverse bias. Clear? Now if it is forward bias, how it will act? How it will act? What is this? It will act as a closed switch. It is in on condition. It conducts current flows. Now if it is off means it is open switch. It is open switch. It is off. It does not conduct. Current will not flow through this terminal. Means it is conducting. What is your input? This is your input. What I applied? Positive. Your output will be positive off cycle. So input will appear across load. V out is equal to V in. Your input will appear across load. So here I will write D1 on. What I wrote? D1 on. This is for positive off cycle. Now I will change the case. As I said, whenever you are answering, the second case will be what? Negative off cycle. For your understanding purpose, write down like this. Now for negative off cycle, what will happen here? Second case, this will get negative, this will get positive. Means what it will become? D1 is reverse bias. D1 will come under reverse bias. D2 will come under forward bias. This will act as a closed switch. Now current will flow. Whatever the input you apply, that is a negative, but you will get a positive supply. This is D2 on. And your maximum peak voltage is how much? Vm. Like this. Now again, if I have a positive off cycle, this is sinusoidal wave. This is sinusoidal wave, continuous waveform. What you will get? D1 on. Same thing. Continuously pulsating DC output I got. Clear? This is the operation of full wave rectifier. One more time I will tell you. From second unit, somewhere you write down. Whenever you are writing the answer, any topic from second unit, start first case for positive half cycle. See for positive half cycle what is up in the diagram, the circuit diagram. Any topic, different circuit diagram. Second case for negative half cycle, what is up? Apply those theorem, concept of PN junction diode forward bias, reverse. You can write your own answer. Say sir. You can write, you can understand. Clear with this operation? Say, got it? Say sir. Okay. Now we will express, we will calculate. What we will calculate? VDC and VR. So what is ripple factor? What is ripple factor? Tau is equal to square root of Vrms square divided by VDC square minus 1. This is tau. In the half wave rectifier we got 121%. Now let us calculate what is the value of tau. How much we will get ripple? How much amount of ripple we will get? So in order to calculate tau, what you know? What you should calculate? Sit properly. What you should calculate? VDC and VR. Now I will tell. You need to focus carefully. Let me calculate VDC first. Focus here. What is this my output? What is this output? This is actually a DC voltage. Say yes or no? So this is nothing but V average overall DC voltage, which is your output of full wave rectifier. So how we will calculate? See here. Focus here. Focus here. What is my time period? 0 to pi. Listen here. This width is 0 to pi. Here also this width is pi to pi, means pi only. My maximum amplitude is Vm. Vm, Vm, Vm. Now I will tell this as X, this as Y, this as Z. And I will tell that the time period is same, amplitude is same for every half cycle. Means I can write it as X is equal to Y is equal to Z. So yes sir. Now I don't know the values of X, Y, Z. So yes sir. Will you calculate individually X, Y, Z, or will you calculate any one value? One value. This value will calculate. Say yes or no. That is VDC. What is my range? Right. So focus here. integration. I am calculating V average or DC voltage. Integration. What is my range? 0 to pi. What is my input function? Vm sin omega t. Vm sin omega t. D omega t. That this is nothing but your average or a DC voltage. Because all the values are equal. Time period is also same. You can change the time period pi to 2 pi, 2 pi to 3 pi. It will become same. And my time period is pi, 1 by pi. For this, if you calculate x, you have calculated y. If you calculated y, you have calculated z. So I will calculate only this. So V average or VDC is equal to 1 by pi integration from 0 to pi Vm sin omega t d omega t. That's the function. I take Vm outside. Vm by pi into integration of sin is minus cos omega t pi 0. Clear? If you substitute cos pi, it will become like this. Vm by pi under the bracket, I will take minus under the bracket minus 1 minus cos 0 1. Minus 1 will become minus 2. Minus 2 into minus will become plus 2. That will become 2 Vm by pi. This is VDC. Now I will tell you an important point. After rectifier, what is the VDC for after rectifier? Vm by pi. Now what is this? Now all the values will become double. This value will become double. Vrms will become double. Efficiency will become double. That is 40.6. What you should get? 81.2. I will prove you that. Okay, clear with this? All the values will become double. This is VDC. Now let me calculate. What we need now? Vrms. Anybody in the class? What is the formula for Vrms? I am not asking after rectifier. I am asking how you calculate Vrms. Focus here. Vrms is nothing but square root of that function divided by time period. If I ask Vrms, yes, don't talk. Focus here. Vrms is equal to square root of ratio of square of that function divided by time period. What is that? Square root of 1 by pi. Why 1 by pi? My range is 0 to pi. Integration from 0 to pi. X of t. What is x of t? This is x of t. That is the function. How much now it is? Vm square sin square omega t d omega. Correct? Say sir? Yeah. If you calculate this, I take Vm outside. Square root of 1 by pi. Integration of sin is sin square is 1 minus cos 2 omega t divided by 2 in the range pi 0. Is it 0 to pi? Huh? Sin square, Vm square I have taken outside. Huh? Because I want to calculate RMS value. My range is 0 to pi. I need to integrate only because I am finding a AC input Vrms. This range, complete area. Your Vrms is nothing but another formula, area under one complete side. But I am getting the output at 0 to pi only. I will take integration from 0 to pi only. Why I am integrating means this Vrms in another word is nothing but this is a complete area under one cycle. Because of that I will integrate, I will take it, I will add it. Integration means add. So I am doing that only 0 to pi. Sin square, integration of sin square is 1 minus cos 2 omega t divided by 2. Range is pi to 0. So if you do this, directly you will get Vm by root 2. If you substitute those values, definitely you will get Vm by root 2. Clear? Understandable? Why I am integrating means, yes, don't know. Why I am integrating means because Vrms means the area under one complete cycle. It's not like a half cycle. Complete one cycle. Got it? If you substitute this value, definitely you will get Vm by root 2. That is double only. That is double of Vm by 2 only. Clear? Understood up to this? Say sir. What we need to calculate? Tau is equal to square root of Vrms is how much? Vm by root 2 whole square. That is my Vrms. Divided by what is VDC? 2Vm by 5 whole square minus 1. So square root of Vm square will get cancelled. Y square divided by 4 into 2. This square will get cancelled. I will get pi square divided by 2 square means 4. 4 into 2, 8 minus 1. Clear? Just a simple mathematics. Pi square by 8 minus 1. So tau is equal to how much you will get if you calculate? You will get 48.1%. Definitely you will get 48.1%. What is the ripple factor for after rectifier? 121%. Now here ripple is less. That is 48.1%. So technically, Foley rectifier can be useful for rectification process. We have proved that tau is equal to 48.1. Clear? Understood up to this? So yes or no? Yeah, focus here. So efficiency is defined as ratio of output power to the input power. This is nothing but efficiency. So I will write power directly. I will mention it as we have done with the half-wave rectifier. P will write it as Vi. Here output power means that is your DC output. I will write it as PDC into IDC divided by, as I said, your input power. Input means AC, but keep in mind always AC means RMS. So I will write PAC. That is nothing but PDC divided by PAC. So this PDC can be written as PDC into IDC. And PAC is nothing but RMS. Vrms into IRMS. Keep in mind AC means RMS. Keep in mind AC means RMS. So we know VDC for full wave rectifier and we know Vrms for full wave rectifier. VDC for full wave rectifier, that is 2Vm by 5. That is VDC. We have already expressed. And Vrms is how much? Vm by root 2. Vm by root 2. We know the values of this. We don't know the values of IDC and IR. So I will convert that current into voltage. That will become VDC into IDC divided by RL whole divided by Vrms into Vrms divided by RL. Why RL? Because in the circuit diagram my resistor load is RL. R means resistance load. So this RL will get cancelled. Finally you will get what? VDC into VDC square by Vrms square. Finally you will get VDC square by Vrms. Keep in mind eta efficiency directly after writing this definition, output power divided by input power, directly you can write down this VDC square divided by Vrms square. But you want to understand means express this step by step, you express this, or you, if your memory is good, if you want to remember it directly, you will write down VDC square divided by Vrms. Now eta is equal to VDC is how much? 2 Vm by pi. So directly I will write 4 Vm square divided by pi square. Vrms is Vm by root 2. That will become 2 by into 2 by Vm square. I am directly writing. I am just skipping those steps. Understandable? 2 by Vm square. So this will get cancelled. 8 by pi square. How much that is? 0.812 you will get. Always efficiency is measured in percentage. I will multiply with 100. That is nothing but 81.2%. What is the efficiency for half a rectifier? 40.6. To double it, we will get 81.2%. Whatever the values for half a rectifier are there, you should double them. Clear? We are done with the efficiency. Next, how will you calculate form factor? RMS value by RMS value by average value. Keep in mind, average means DC value. Average, you can write down average or DC value. Our RMS for full wave rectifier is Vm by root 2 whole divided by how much DC? 2 Vm by pi. So Vm will get cancelled. What you will get? Pi by 2 root 2. Pi by 2 root 2. How much you will get? 1.11 I think. I think you will get 1.11. Form factor is for full wave rectifier it is 1.11. Now what is the next factor we have? Peak factor. Peak factor. So name itself suggesting you peak factor. It will have a peak value. So that is nothing but it is the ratio of peak value divided by RMS value. So peak value is how much? Vm. So peak value is always Vm. In the sinusoidal input waveform, output waveform, my peak value is Vm. That is peak. This is 0. That is peak. Peak value is always Vm. What is RMS value? Vm by root 2. Vm will get cancelled. Will get root 2. That is the peak factor for full wave rectifier. So when the question comes, this total will be divided into part. You may get a question like this. Listen carefully. Explain half a rectifier with neat diagram and derive VDC or and derive VRMS. He may ask either you will get VDC or to derive VRMS or combining these things. One more question. Explain full wave rectifier with neat diagram. Draw the diagrams. Explain the operation. Read the question and derive ripple factor or derive VRMS or derive VDC. Any one derivation. Understandable? He may ask VRMS or he may ask VDC or he may ask these efficiency, form factor, peak factor. And you may get one more question also. Efficiency, form factor means what? Peak factor means what? One mark definition. Clear? Understandable? Got the differences? Got understood what do you mean by half a rectifier? What do you mean by full wave rectifier? So based on this, let me give a differences between them. Let me give a differences between them. So what we will do? Here we will write a particulars. One column, second column half wave rectifier, third column full wave rectifier and bridge rectifier. I have already explained this bridge rectifier. Where I explained? Regulated power supply. In bridge rectifier we have 4 diodes. I already explained that. So take a table like that, draw the table like that. Yeah, do it. I will tell you the differences. అది pause చేయవా Draw the